Alright, this video is going to be your homework answer keys to the word problems. It says Pythagorean Theorem Word Problems number 1. So here we have number 1, and we have a ladder that's against a wall, and the ladder is a 12-foot ladder, and the base of the ladder is 3 feet from the wall. So this sketch is not to scale, but that's okay. We can still figure it out. We need to figure out how far up the wall the ladder is. So Pythagorean theorem allows us to take a leg squared and add it to a leg squared instead of equal to the hypotenuse squared. So here we have root 135. And in this case, we want simplified radicals, so you need to be able to break your radicals down. So if we go ahead and find some factors of 135, we get 9 and 15. Again, I try dividing by a perfect square so that it's easier for me to break down. And then 15 would break down to 5 and 3. So my coefficient is 3 and my radicand is 15. Okay, in number 2 here, we have a rectangle, and our rectangle is 90 meters wide and 120 meters long. We need to find the length of the diagonal. So in other words, we need to be able to find the hypotenuse. So a leg squared plus a leg squared equals the hypotenuse squared. And if we notice, if we divide by 10, we have a 9, 12. And that 9, 12 is a nice multiple of a 3, 4, 5. So we increased a 3, 4, 5 3 times. So as long as I take 5 and multiply it by 3, I'm going to get the 15. And then remember, I had already sized it down by 10. So that means my diagonal should actually be 150. Okay, without using the triples, you have a lot more algebra to work out. Okay, remember that's because we squared both sides. Okay, number 3, again we have a house and the ground and a ladder, and our ladder is a 15-foot ladder, and we want it to reach 12 feet, so we need to find the ground. Alright, so we have a leg squared plus a leg squared is equal to a hypotenuse squared. Again, noticing I have a 12 and a 15 and then x. And the greatest common factor between these two would be a 3. Let me change this. The x is the leg. The 15 is the hypotenuse. The greatest common factor is a 3. That's a 4 times 3. And this is a 5 times 3. So my triple would say that I need to have a 3 times 3, giving me a 9. So we can confirm that. Okay, so again, you'll see how the triples make the work a lot easier once you get the hang of it. Number 4 is similar to number 2. We need to find the diagonal if we have a 10 by 15 field. So a leg squared plus a leg squared is equal to a hypotenuse squared. All right, so I have to break this down, and again, I'm looking for factors that would be perfect squares, and the first one that comes to mind is a 25. So if you think you have $3.25, how many quarters do you have? So we would have 13 quarters, and that gives me my final result right there in 2 steps rather than breaking down into a really big factor tree. So if 5 root 13 doesn't mean much to you, if you looking at it as a decimal, that would become 18.03. That may have some more significance to you, but you want to start to be able to break these numbers down and say, all right, root 13 is between root 9 and root 16. So this value of the radical must be 3 point something, something closer to 4, so maybe 3.8. And so that times 5 would allow you to see that it's about 18. All right, another rectangle. So by now you should start to get the hang of it, but this one changes because we're given the width of 15 and a diagonal of 25. So we need to be able to find a leg. So when I look at this, I say, okay, is it at all possible that I have a triple? So common factors would give me a 3 times 5 and a 5 times 5. So that 3, 4, 5 is being increased 5 times. So x is 20. And you can go ahead and confirm that with Pythagorean theorem if you'd like. All right, 6a. We're given a triangle that has legs of 8 and 12. And remember, the legs are the altitudes. The area of a triangle is base times height divided by 2. That's also the same thing as base times height times 1/2 or times 0.5. So my base and my height are always the things that are perpendicular. So 8 times 12 divided by 2 would give me 48. And that's inches squared. But now in 6b, they give us the hypotenuse of 12 and a leg of 8. So we need to use Pythagorean theorem to be able to find the other leg so that we can solve. Okay, so again, we're looking at 80 saying, is it divisible by a perfect square? So not 9, but 16 would work. So that gives me 4 root 5 as my side. So now, in order to find my area, I need to say 4 root 5 times 8 divided by 2. So my 8 and my 2 will reduce to be a 4, and that will give me a 16 root 5. And root 5 is a little bit above 2, so I know my final answer would be something that's a little bit above 32 if I happen to round it. So 16 root 5 inches squared. All right, number 7. My square has an area of 81. And the area of a square is side squared. So if a side squared is 81, the side must be equal to 9. Each of the sides are 9, so my perimeter becomes 4 times 9, which is 36, and they are centimeters. Okay, number 8, I have an isosceles triangle, and the congruent sides are 20 centimeters. My base is 10 centimeters, and if I notice here, in an isosceles triangle, remember our altitude, which we know we have because it's perpendicular, is also our perpendicular bisector. Okay, if you didn't remember the fact that it's a perpendicular bisector, you want to take note that you have congruent right triangles by HL. Therefore, these would also have to be congruent. So that breaks that 10 up into a 5 and a 5, and now you can go ahead and use Pythagorean theorem that a leg squared plus a leg squared is equal to a hypotenuse squared. Again, breaking down into 25 would give us 15, so we have 5 root 15. All right, our baseball diamond gives us sides of 90. If we threw the ball from second base to home, we're finding the hypotenuse of the right triangle. So I know this is both were made up of 90s to begin with. So I know I must have a multiple of a 90 in here. So 16,200 divided by 90 is going to give me 180. So I could have broken that down that even more. So then that's a 30 root 180. So that's a 30 and a 90 and a 2. So I have to pull another 30 out, giving me a 90 on the outside. So this broke up into a 30, and I had that 30. So I multiplied those two together to get that 90 root 2. And that was my final answer, and that was number 9. Okay, our last one, number 10, gives us a table, and we're going to have to check out that diagonal because it's 42 wide and 84 tall. So the table is 96 inches in diameter, so clearly she's going to have to put it in on a diagonal inside. So if we take a look at this, we have Pythagorean theorem finding the hypotenuse. So we have 42 squared plus 84 squared is equal to x squared. So that would be 1764 plus 7056 is equal to x squared. So when I combine those together, that's 8820. And then I need to be able to take the square root of that. So if I divide that by a perfect square, let's say we take and we divide it by 36, and then we get 245. And then we need to break 245 down. And so that 245 breaks down into 49 and 5. So I pull the 7 out, multiply it against the 6, and I get 42 root 5.